So, uh, as I was just saying to finalize, my entire career has been in artificial intelligence. I have built teams. At Emirates, built a team of engineers and scientists that really did a great and amazing work. I'm also a practitioner, hands-on. I am now building another team for AI. I've done in London and all over the world before, build solutions, teams, capabilities, algorithms all over the place. So I just wanted to also highlight to you that I'm a very hands-on individual, leader, but mentor, and somebody that can stick together with engineers and science side by side, building capabilities. And what I'm going to share with you today is really some of those thoughts around the line. So I think before we start, so let's if we do a quick deep dive into secure AI. So, what's the problem we're facing, and why is this a problem that enterprises are actually addressing it? So, first thing I wanted to say, it's really the humans, us people, that are requesting for more fairness in AI, transparency, which ends up being achieved by a little bit more regulation, a little bit more privacy, and so on and so forth. So one of the things that happened, for example, in UK very recently, is that the government was trying to adjust the students' grades on their applications for the universities. And turns out that the models that they were using had some bias towards some ethical related questions. Example, the income of where the student was located, the area, and some additional attributes uh, related to the location of those students, which basically made the students come all out and say, we want more fairness in your algorithms that would not adjust the grades as is currently doing. Because if I'm on a very poor area but I'm a phenomenal student, my grade is actually being downgraded, which prevents me from accessing some interesting universities, and I don't want to do that. Another quick example of this is, for example, the Apple Card, which you had some people kind of complaining online that it was the sexiest program. Just to give you an example, a wife and a husband joined their tax returns, lived in a community property state. They have been married for a long time. And the algorithm was giving him 20 times more credit limit than would give to her. So again, that's another example where people are start to demanding transparency and fairness in AI. Finally, but not the least, Amazon had a particular tool where it showed some bias against women. So if you think about, you know, um, you apply for a job with Amazon, and you were a woman, you were probably very unlikely to, get some response back when this tool was being created. Of course, Amazon corrected, but this is just some examples of what's going on around the world that actually has been increasing the need for secure AI. So, what is really the secure AI mission? The secure AI mission is making everybody feel safe with artificial intelligence. The makers of AI, people like me and some of you, people that actually do machine learning at scale on enterprises, and the consumers, our customers, um, everyone, our kids, our grandparents, our parents, our wives, husbands, and so on and so forth. So it's really making all of us feeling safe with AI. So if we take that as a motto within AI, and if you are able to break it down into secure and insecure AI, what actually underpins secure AI? So first thing, organizations that are addressing secure AI, they are really thinking about, how do I protect data? How do I ensure that data is protected to fuel artificial intelligence? How can I give the data scientists access to protected data so that they can still build and deploy machine learning models at scale on top of protected data? So that's one. The second one is they're really trying to reduce ethical bias. So, for example, um, the Amazon example before, they really look at the solution, the recruitment tool, look at the model, understood what was the model actually predicting from, realized there was an issue with gender and corrected, and then released the app again with way less ethical bias. And as a result, they can claim that they are playing a role in secure AI because they really address one of the biggest challenges that we're going to have in the future with ethical bias in some of the algorithms. And finally, in some places around the world, I'm thinking about GDPRs and equivalents, and I know there was just a very similar regulation in the UAE, for example. You will have um, a regulation that will force you to do these things if you're not trying to do them on your own. So, recapping, I think the organizations that are really addressing secure AI will be protecting their data. And protecting their data, I'm not talking about network security. I'm talking about data privacy, data security, protecting the individual data points in your databases, whatever it is. We'll see an example of that in a second. Reducing the ethical bias, and being compliant with regulation. But here's the good news, and this is one of the big messages I wanted to share with you today. If you are doing all of this, it basically means you're having faster access to protected data. And if you tell data scientists all around the world, and this is one of the biggest problems we have in the industry, is data science are still data hunters. They go across the organization for the particular use cases they're trying to solve, and they are hunting for data. If you are protecting it, you have built the framework with your privacy officer and security officer in the different departments, and the data science can access way more data than before protected. And you can do a lot with protected data. We'll see that in an example in a second. If you are thinking about ethical reduction on bias, compliance, and etc., you will definitely see a significant acceleration of development and deployment of AI, which basically would mean that you are enabling higher volume and diversity of AI use cases, which is great. Finally, that just gives you more value. So if you have faster access to data, faster AI development and deployment, more volume and diversity, it would mean you are delivering these use cases more often, and you're generating more value to the world. And that basically aligns to the overall mission of making every person feeling safe with AI. So that's a very important statement. Everything you're going to see next underpins this particular secure AI notion. So let's deep dive into this. So secure AI then starts with you're working with protected data. What does this mean? So here is a data set, and I'm just giving you an example with the data set. This is the data in a clear, okay? And so this might be in a cloud database like Snowflake, Redshift. This could be on-prem with Oracle, IBM, Teradata. This could be MySQL Server. This could be a combination of clouds. This could be a contact center database. This could be many things, right? So the important thing here is this is the data in the clear. And we in the industry, especially in data science, need to learn how to work with protected data that gives us the exact same output. Example, if you had a solution of encrypting the data, I'm not saying encrypting the files or the databases, I'm talking about encrypting the data points, the first name, the last name. You see the columns on the database hasn't changed, but you actually protected the data related to that. So why is this important? When you protect the data with a technique like encryption, you will get one of the things that you will get right out of the gate is you will get referential integrity. So if you protect first name with encryption and you do that in 5 databases, on-prem, on cloud, on S3 or equivalent, you have protected first name in the exact same way. So a data science can join data based on first name, on encrypted first name, and you can still join all the data as you do today. That's super important because it gives you what I call the ability for you to accelerate your data pipelines for AI. That's really important. However, the encryption technique that you choose, and there's a few, have the challenge of when you implement the protection of the data, you have to change the database types or the file types because this is no longer a string, basically a character with, I think this name was Jeffrey before, right? So it has like seven characters. This is now something completely different. So you might have to change the data type. And the same applies for email and so on and so forth. But there are other techniques like tokenization, where you not only protect the data across your entire state, databases on the cloud, on-prem, in the exact same way, but in addition, you still have referential integrity, meaning you will protect first name and last name in exact same way, but you preserve the data type. So you maximize the utility of the data by having referential integrity, which is great. But in addition, you don't have to change the data structures of your databases to put the data protected. No, we as a data science, we very likely don't need to know the first name and last name and email of this particular data set. However, sometimes some data is organized by name or by social security number or some other parameter, and we need to join the data accordingly. So this gives us acceleration. I don't know who this first row is. It's totally protected, but I can still use it. And that's the important thing of right out of the gate working with protected data. So that's one thing that I wanted to just explain before we go on with secure AI underpins working with protected data. The second thing that I want to talk to you about, and I'll leave, of course, time at the end for questions, is the different kind of concepts between responsible AI and confidential AI, which we're going to see some deep dives, and I'll illustrate two quick examples. So the first one really is, responsible AI. What it aims is basically when you are working with protected data, um, you basically aim to solve the problems of regulation, privacy, trust, ethics related to the decisions made by the machine learning models. And that's on the responsible side. And the confidential side is everything in responsible plus decentralized AI. So let's deep dive into this to understand what it means. So in responsible AI, when you think about it, so you're working with protected data, and you're not going to try to essentially address the problems underpinning responsible AI, regulation, compliance, privacy, and so on and so forth. You have a series of capabilities there. So you are working with protected data, as I just described. Hopefully, will be a source of techniques like the ones shared. And then you're going to address the remaining aspects of regulation, privacy, etc., by bringing things like data anonymization, with some of the techniques that I mentioned there. You're going to address synthetic data, or you're going to have libraries on machine learning that already brings differential privacy. For example, um, let's say in GDPR, you have a million records data sets, and the GDPR says you can only use that for AI if you have at least 10 individuals in a data set that look the same. So if you have things like city, age, and some additional parameters that are considered to be identifiers of you, we will have to generalize that data to at least have 10 individuals that look the same, meaning part of the same age group, city, and so on, for the model to be compliant. So data anonymization can really help you with that. Recently, a bank in Canada shared a synthetic data science use case where they were trying to predict fraud. They wanted to give the data set for a third party, and they created synthetic data. They built a machine learning model that generated similar data to transactions on the bank and share that with a third party for them to build a fraud model. Now, if you create proxy data with synthetic, leveraging GANs, for example, the properties of the data, the statistical properties of the data are kept. So when you create a proxy data set, you can share it with your AI team and so on and so forth, and it might be able to give you similar capabilities for you to build models on that synthetic data. So that's two quick examples there. That it's important. So the number one is you generalize the data. The second, there is a way for you to create synthetic versions of it. On the confidential side, you really have two aspects that are important to call out as industry kind of developments. One is machine learning on encrypted data and federated learning. So the first one is when you have a big group of companies with entities all over the world in different geographies, and they want to share all data for a machine learning model to run. But neither of them, through regulation or etc., can share the data with each other. So they're going to use this fifth middle block to basically each one of them will have like a data set with a schema that they put into this fifth environment where somebody's going to build a model and then make the model available as an API for all the four. But neither who's building the model or each individual entity can see each other's data. Now, the principle here is every entity participating in this are working with protected data. They might even have to add data anonymization. And the fifth environment may need to use some of the latest encryption techniques to ensure that whoever is building the model cannot access the full data set to build the model. Federated learning, and I'll give you an example of the national security of US that recently presented this use case. Is a similar concept than the one on machine learning on encrypted data. However, the data does not go to the middle, or in this case, to the model. Imagine you have an environment here in the middle where you want to build a model, and you basically create a connection, a secure connection between this middle environment where the model is and the data that could be on a device or on a database. And the model goes to the data, trains locally in the device or in the place where the data is, trains it, and then comes back to the middle, updates the weights, and then does this across the parties that are involved in this consortium, and then finalizes, and the model stays in the middle, but the model never required the data to come to him. He went to the data. So that's also a very important development. The confidential AI will enable use cases that we have never experienced before. For example, we might want to solve a particular cure for a disease. And it required us to have 50 hospitals to share data with each other, with images or so on and so forth, where we can actually apply some techniques. Now, both of these use cases, machine learning on encrypted data, federated learning, enables that kind of developments and innovations. We haven't experienced this in the past. The same is true if banks are trying to collectively solve human trafficking, for example, where money gets spread across different banks, and we need data to be kind of shared between them to tackle. So we are really opening a large amount of new use cases that before, through security and privacy concerns, we were not able. And both of those, encrypted and federated learning, does assume you're working with protected data. And that's really, I think, from my perspective, the latest advances in the artificial intelligence world that I would like to share with you today. So let's go through a final architecture pattern slide. I'm going to focus on the responsible AI because I think it's where it resonates well or more with a single entity, a single enterprise. So I'm going to now try to bring everything together that I've walked you through some sort of an example on patterns that I think will resonate well. So when you have use cases, let's say you arrive at data science and you say, hey, here's the data science use case, go and solve it. The first thing I'm going to think is, oh, I need access to this data, that data, that data, that data, that data. So this process could be a year to just get access to all the data, or it could be zero time waste if the data is protected as I just described to you, the security team is comfortable, the privacy team is comfortable, the business is comfortable. I just have to say that's the data sets I'm going to access, because um, I'm not actually consuming anything that I shouldn't. The second thing, so that's the first architecture patterns, is work with protected data, as I explained to you, because protected data has referential integrity, enables you to accelerate your development lifecycle, and it's a way for you to be compliant right out of the gate with security patterns that you have in your enterprise. And there isn't actually something in protected data that disables you from doing AI, which is a really important shift paradigm for all of us. The second thing that I wanted to share with you today is, today you may have your warehouse on Snowflake, Redshift, Teradata, whatever. That warehouse, protected warehouse, needs to be available for your AI platform. You could be having Dataiku, Data Robot, SageMaker, whatever. When you're building that model, you're going to access protected data. When you are building the model, building and deploying the model, you want to make sure you bring data anonymization into the mix, or the differential privacy for that matter. You can use k-anonymity. So there's different techniques you can use. So data anonymization is a privacy model that takes one data set as an input, maybe 1 million records, and generalize it to a particular compliance that you have. So you bringing that to the AI life cycle enables you to build models that are compliant with regulation, number one. Number two, you are able to reduce ethical bias, but reducing ethical bias will have an impact on the accuracy of the model. Because if you generalize more the data, the utility drops and therefore the accuracy drops. So you're going to have to essentially create a mechanism in your enterprise to create different models at different levels of accuracy and show the trade-off between privacy and accuracy. And of course, there's an inherent risk associated with that. And as you deploy the model through your DevOps lifecycle with potentially some human intervention in the middle to review those trade-offs, you're going to have to create this body that reviews the models before it gets deployed, that will analyze the risk associated with the model. Take the example of the Amazon tool, for example, because you still wanted to be able to do pricing, loyalty, customer, next best offer on the website, recommendation systems. You want to do all of that, but you want to make sure that the models are compliant, the models don't suffer from ethical concerns. And a great weapon for that is really mixing the anonymization with protected data to address those concerns. Now, you build the model and you deployed it on protected data, and it's compliant and it doesn't have ethical concerns. Now you need to integrate it, because the model that was deployed still needs to be available for the website, your application, for other, etc. And here, the model may be used as an API for those website devices, etc. And this integration is really important for you to think about this way. So if it's a real-time use case and you have a need for calling an API for the model, maybe it's the next best offer, maybe it's the pricing, whatever. When the application, the website, the device, or etc., calls that API, it doesn't understand the model language, because remember, you are working with protected data and you have anonymized it. So there needs to be something like a broker, like a gateway, that takes the request from the application or the device and applies the same rules of protection and anonymization that your model understood. Otherwise, the request will reach the model on a language they don't understand. And as a result, the model cannot give the prediction. So by you bringing protection and privacy into the model when you're building and deploying, you also have to address, when you make requests to that model, that transformation needs to happen in real time as well. So important 3 key patterns that I shared with you today. Work with protected data for your use cases. That accelerates it dramatically, because you don't have to waste time agreeing on how you're going to access the data because it's protected. Address regulation and ethical bias with anonymization. And important as well, look at technologies with gateways that enables you to bring the rules of protection and anonymization to real-time APIs, so that you can call them on the fly as you wish for you to convert the model API into something else. I hope you really enjoyed what I just shared. I'm going to open now for questions and maybe any particular thing that you wish. So
Thanks
I'm
a
going
lot.
to.
Thanks a lot for the presentation. So yeah, Manoj has a presentation. Go ahead.
Okay, am I audible?
Yep.
Okay, so Eliano, you talked about a very important aspect of data anonymization, right?
Mm-hmm.
So I was curious to know, specifically in terms of machine vision, when we talk about how the data anonymization can take place when you have to work on actual images, right? How you can anonymize them.
Sure, it's a great question. So, of course, I'm going to go back to this particular slide. So, different types of AI will require the use of different techniques. So, for example, if you are trying to anonymize, so if your use case is using images but does not need to do anything different from recognizing that there is an individual, but you don't care about what individual it is, the anonymization here would follow a strategy of pixel reduction, which would still enable the algorithm to detect there is a human there, but actually you have downgraded the face so that you can't recognize the things that you want on that particular image. Another solution for that is for you to have a synthetic data approach where you first run a synthetic solution which takes the face and puts the exact same picture with a proxy individual that doesn't exist. And from that perspective, you become compliant again. So when you are really thinking about computer vision, you really have to go back to the suite of techniques and see which one adapts better for the use case that you're solving. Hopefully that made sense.
Sure, yeah.
Thanks a lot for the question. Thank you so much. Yeah, thanks a lot.